Hi, this is Ryan Linfield. I had a question come in today regarding the difference between network address translation and actually purchasing the firewall. Is a dedicated firewall any different from just simply using NAT? It's a bit more complicated than that, so let's take a look at whether the traffic is going to be outbound or inbound real quick. We'll start off with just Exhibit A here. And with Exhibit A, we'll just have outbound connections going to the internet. So we've got a device here in the middle. Let's say that it's a traditional router of any vendor, and this router is performing network address translation. What that really means is we've got private addressing on the inside, like 10.0.0.0/24, and we've got some type of public IP address on the outside. A lot of times, this will come via DHCP from a provider. There will be one single IP address on the outside interface. You'll have many devices on the inside, things like Xbox, PlayStation, televisions, crockpots, treadmills, tablets, phones, PCs, laptops, all wanting to get out. What that really means is that we've got many addresses on the inside that are overloading to a single IP address on the outside. So it's not technically NAT anymore, it's NAT with port translation, sometimes described as NAT PT. I usually just call it padding or port addressing, also called NAT overload. Now what makes this secure is that you can get from the inside to the outside, and we can look things up all day long. Every time you make an outbound connection, that connection is going to be recorded in a translation table, and traffic that is replying to that exact connection is going to be allowed back through. When there's a just random session that's trying to be initiated from the outside, when that comes into the firewall, he looks at his translation table, he wouldn't see a match, so that packet would be denied. So in summary, using port address translation, you have outbound connectivity, but you're not going to have any type of inbound connectivity by default. So let's go a little deeper. Sometimes when we set up NATing, so once again, we've got NAT with port translation, also called PAT, enabled on this router. Even simple devices like a Linksys or Netgear or D-Link, those Soho devices, have the ability to do port forwarding. And what we do with port forwarding is we just listen on the outside. So once again, the outside interface will have a public IP address that comes from your service provider. And all we simply do is say, if anything comes into the firewall on port 80, now forward it through to, maybe I've got, Plex or something installed, and I've got a Plex web page running on port 80, and I want to stream a movie outside of my outside of my home. Well, in that scenario, anybody from the internet that comes in on port 80 is going to be passed through, and they'll hit, let's say, the Plex server. Well, again, this isn't a traditional web server like IIS or Apache. This even though it isn't, it still has the ability to process your standard HTTP commands, and it may have vulnerabilities within it that could allow the system to be compromised. If that were the case, the NAT device didn't really provide any sanitization of what's coming in over port 80. So simple NATing with outbound rules, pretty good from protecting anything on the inside from traffic coming in that we didn't really want. As soon as you start to do things like static port forwarding into existing services, if there's a vulnerability in that service, it could be exploited. And now this system has unrestricted access to anything else within your environment. So if you've got, maybe your wife's laptop's over here, you've got a baby webcam over here, all that type of equipment is now going to be accessible from that compromised system, potentially. So it's just things to think about. What happens when we open up that port and we start allowing things to come in? So that's just looking at, how network address translation plays a role in this. One of the other things we could do is start to look at access control lists. Now, it doesn't necessarily need to be a firewall per se to leverage ACLs. Even routers use access lists, even Windows and Linux, you can put an ACL on a particular service. And all we're going to do is have this simple kind of fork in the road for, do we want to permit or do we want to deny traffic that comes from, and then we specify some details. Those details could be source and destination IP address, source and destination port number, even time of the day. By simply adding filtering like this to the outside, we're starting to come back and restrict what we allow in. Again, when we talk about using ACLs, we're filtering based on packet data. When I say that, I want you to think of an envelope. We're thinking of layer 3 and layer 4 information, IP addresses and port numbers. We're really not opening up that envelope to look at what's inside of the contents. So let's move to a new example. If we're not just simply NATing, and you do actually have a firewall, and the firewalls that I teach you about are the Cisco ASA. So he has the ability to do the layer 3, layer 4 filtering. So when I say that, I'd like you to think of NAT and access control list. He also performs stateful packet inspection. You'll see that abbreviated as SPI, stateful packet inspection. And what that means is we look at certain applications like TCP. And with TCP, we want to see the three-way handshake at the beginning. If there's not a three-way handshake and traffic just comes in with something like a SYNAC set, we know that a session has to be established first. We need to see the initial SYN followed by SYNAC followed by NAC. Once it reaches the established state, data can be transferred. So with stateful packet inspection, we'll do things like look at a TCP session, make sure the three-way handshake completed. We'll take a look at the sequence numbers, and we'll be sure that they make sense. Make sure no one's doing something like a blind TCP packet injection. If you want to get a little bit more granular, we can start creating rules for what's abbreviated, more abbreviations, DPI, or deep packet inspection. Deep packet inspection means we're going to take that envelope, we're going to open it up, and we're going to look at what's inside. Or in other words, instead of looking at layer 3 and 4 criteria, we'll go ahead and we'll filter based on that. But now we're going to open up the payload, which is, by network folks, it's just referring to everything that's inside at layers 5 through 7. So we open up this envelope, we take a look inside, and using a little bit smarter firewall, what they sometimes call a next generation firewall, you have the ability to do application inspection. So I could look inside of this and define, are there things that I like or don't like about the way that the HTTP is formatted? Are there particular HTTP methods that are inappropriate? When you look at applications like websites, there's a number of HTTP methods that you can use. You can delete files, you can even print through a web service. You can do debugging over HTTP using a method called trace. So what we could do is we could create a whitelist or blacklist for HTTP methods that we wanted to allow. You could also specify some boundaries. You could say the maximum length of a URL that anyone should ever request is, and you would define how big that is after evaluating your websites. You could do the maximum download length. You could look at things like emails and say the maximum number of recipients. There's lots of filtering that you can put into beyond just looking at port numbers, and that's what a better firewall is going to do for you today. Not only give you the ability to perform that type of inspection, as Cisco has, but also give you the ability to create rules in a little bit more easy of a way. So historically, we had to use these kind of logical, clunky constructs called class maps and policy maps and inspection policies and so forth. With Cisco's Firepower, this is where they take the technology from SourceFire and they're tying it into the ASA. They kind of layer it on top for the application inspection. You get a little bit prettier of an interface to build policies with, and then those policies are applied to your application layer traffic. So another way to think about that is if we look at a Cisco ASA again, and we say for the layer 3, layer 4 functionality, which is pretty critical. You know, we're looking at things like the TCP sequence numbers. We're looking at even, you know, layer 2 criteria as well, because we could be a transparent firewall. Everything that has to do with regular old packets is going to be handled by your ASA logic. And then we've got what they're calling firepower, and this is the SourceFire intelligence. And what we do is we take certain traffic flows and we hand it off to Firepower. Firepower is going to go ahead and it's going to apply rule sets against the application. So we could do things like URL filtering. We could specify based on app ID. We could look at applications and websites such as Facebook, and I could say Facebook is okay, posting pictures is not okay, commenting via text is okay though. But maybe games are not okay, but Messenger is. So you have the ability to go through here and granularly permit and deny specific, what you'll sometimes see this described as micro applications from going through a firewall. Again, the alternative to that is just simply, using NAT, which gave you a little bit of privacy. It didn't let anybody in, but you didn't have these rule sets that are more granular, defining what can come in and what can go out. Anyhow, I hope that answered your question, and thanks for writing in.